Hello dear viewers, this is AI Voice Gary, speaking to you as Buddy from Town's narrator. Since Buddy began his exploration of the cosmos, he has become interested in current news about the universe. Today, Buddy from Town is sharing news about a husband and wife team of astronomers, who established the star formation history of a post-starburst galaxy, using its cluster population. They joined forces for the first time in their scientific careers during the pandemic, to develop a new method to look back in time, and change the way we understand the history of galaxies. Posted on ScienceDaily.com, Dr. Rupali Chander, Professor of Astronomy, and Dr. J.D. Smith, Director of the U Toledo Ritter Astrophysical Research Center and Professor of Astronomy, merged their areas of expertise, while working along with University of Toledo alumnus Dr. Adam Smersina, who is currently a postdoctoral researcher at the University of Washington. The resulting breakthrough research, published in the Astrophysical Journal, outlines their new method to establish the star formation history of a post-starburst galaxy, using its cluster population. The team used NASA's Hubble Space Telescope to focus on a post-starburst galaxy, nearly 500 million light-years away, called S12, that looks like a jellyfish with a host of stars streaming out of the galaxy on one side. The astronomers used well-studied cluster masses, and star formation rates in 8 nearby galaxies, to develop the new method, which could be applied to determine the recent star formation histories for a number of post-starburst systems. The researchers applied their different approach to S12, which is short for SDSS 623520512007, since it was discovered and catalogued in the Sloan Digitized Sky Survey. The approach uses the age and mass estimates of stellar clusters, to determine the strength and speed of the starburst, that stopped more stars from forming in the galaxy. Using this method, the astronomers discovered that S12 experienced 2 periods of starburst before it stopped forming stars, not one. In the article, Dr. Chander says, clusters are like fossils. They can be age-dated, and give us clues to the past history of galaxies. Clusters can only be detected in these galaxies with the clear-eyed view of the Hubble Space Telescope. No clusters can be detected in even the highest quality images taken with telescopes on the ground. Dr. Smith has led several large multi-wavelength projects to better understand the evolutionary history of post-starburst galaxies. He discovered, for example, that the raw fuel for star formation, gas and dust, is still present in surprising quantities in some of these systems, including S12, even though no stars are currently being formed. While studying the light from these galaxies at multiple wavelengths has helped establish the time that the burst happened, said Dr. Smith, we hadn't been able to determine how strong and how long the burst that shut off star formation actually was. And that's important to know to better understand how these galaxies evolve. The study indicates star formation in S12 shut off 70 million years ago, after a short, but intense burst, formed some of the most massive clusters, known with masses several times higher than similar age counterparts forming in actively merging galaxies. The method also revealed an earlier burst of star formation that the previous method of composite starlight modeling could not detect. Smith noted, these results suggest that S12's unusual history may be even more complicated than expected, with multiple major events compounding to fully shut off star formation. The research was funded by the National Science Foundation and NASA. Star clusters are large groups of stars. When stars are born, they develop from large clouds of molecular gas. This means that they form in groups, or clusters, since molecular clouds are composed of hundreds of solar masses of material. After the remnant gas is heated and blow away, the stars collect together by gravity. 2 main types of star clusters can be distinguished. Globular clusters are tight groups of hundreds to millions of old stars, which are gravitationally bound. Open clusters are more loosely clustered groups of stars, generally containing fewer than a few hundred members, and are often very young. Open clusters become disrupted over time by the gravitational influence of giant molecular clouds, as they move through the galaxy, but cluster members will continue to move in broadly the same direction through space, even though they are no longer gravitationally bound. They are then known as a stellar association, sometimes referred to as a moving group. Star clusters are important in many areas of astronomy. The reason behind this is that almost all the stars in old clusters were born at roughly the same time. Various properties of all the stars in a cluster are a function only of mass, and so stellar evolution theories rely on observations of open and globular clusters. This is primarily true for old globular clusters. In the case of young and intermediate age, factors such as age, mass, and chemical compositions may also play vital roles. Based on their ages, star clusters can reveal a lot of information about their host galaxies. Clusters are also a crucial step in determining the distance scale of the universe. A few of the nearest clusters are close enough for their distances to be measured using parallax. A Hertzsprung-Russell diagram can be plotted for these clusters, which has absolute values known on the luminosity axis. Then, when a similar diagram is plotted for a cluster whose distance is not known, the position of the main sequence can be compared to that of the first cluster, and the distance estimated. This process is known as main sequence fitting. Reddening and stellar populations must be accounted for when using this method. Nearly all stars in the galactic field, including the Sun, were initially born in regions with embedded clusters that disintegrated. This means that properties of stars and planetary systems may have been affected by early clustered environments. This appears to be the case for our own solar system, in which chemical abundances point to the effects of a supernova from a nearby star, early in our solar system's history. This concludes Buddy's Space News today. If you would like to follow along to see Buddy from Town become Buddy of Singularity, please click subscribe, and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.